Hello, in this video of INEN 2373, we're going to continue with the application of the concept of time value of money. Particularly, we're going to talk about bonds. So bonds are investment vehicles we can use to finance corporations or governments at every level, federal, state, or municipal level. If, let's say, for instance, a corporation issue a bond, this bond would have a face value. The face value could be, for instance, $1,000, and that would be written on top of the bond. There is also associated to the bond a bond rate, which is the rate that the company is committed to pay to the face value. So, say for instance, a bond rate is 5% and the face value is 1,000, then that means that the company is going to pay every so often, typically every year, coupons, and each coupon would be, since the bond rate would be 5% out of 1,000, each coupon would be $50. So the way that the instruments are designed to operate is that the investor buys it at a purchase price. Ideally, would be the face value, and then the purchaser will receive the coupons every so often, typically every year, but it could be every 6 months or every 3 months. And these coupons will be received as the payment of exclusively the interest associated to it. So the bond rate is an interest that the company is paying to be financed by so many dollars. And at the end, the redeeming price would be the face value, and the company is committed to pay at the last payment the amount for the last coupon and the original face value. However, the purchase price and the selling price might not be always the face value, and we're going to discuss that. Corporations, as well as states and governments at any level, get evaluated in terms of their capacity to pay their debts. So there are three main companies that qualify the debt for each one of the corporations that issue bonds, and these are Moody's, S&P, and Fitch. S&P stands for Standard & Poor's. So there are qualifications. Some of them at the top are qualified AAA or AA plus or AA, and so on and so forth, depending on each one of the agencies qualify with a different form. Those would be at the top. Then you have some that are in the middle. Again, these same companies qualify the capacity of the companies to pay their financial commitments as triple B or double B plus, and so on and so forth. And at the bottom, these same companies might classify the companies that have problems or are highly vulnerable to in a financial situation as C, triple C, or D, and so on. So depending on the qualification of the company, these companies get different investment grades. So let's consider two companies, one that is AAA and the other is triple C. Both issue bonds for $1,000 in the face value. Both issue the same bond rate of 10%. Therefore, both the coupons of these bonds would be $100 each. And the yield is how much actually the purchaser is going to receive back in terms of percentages, depending on how much they had to invest. However, as you can see from the qualifications, why would you want to pay the same amount for both bonds? You wouldn't want to do that. You would be willing to pay more for the AAA bond than what you're willing to pay for the triple C bond. But that implies then that you're investing more for the AAA than what you're investing for the triple C. So in other words, you are willing to sacrifice some of your profits for the sake of safety. In other words, the higher the yield, that is, the higher the return you get, the higher the risk that you get. So The triple C bond would have a lower price than the triple A bond when everything else is equivalent in terms of face value, bond rates, and coupons. But at the same time, the yield would be higher for the coupon that has more risk. In other words, if you're willing to take some risk, you probably will be willing to, or you might receive better yield, but at the same time, you are running a risk of not getting your money back, and that's the essence of what's going on. So, companies that have the same investment grade in their bonds, say AAA, all of them, if they have their bonds have the same time till maturity, that is the time when the face value would have to be redeemed, then all of them would have about the same yield. And because they have the same yield, then it might be possible that the price would need to be adjusted. So in other words, depending on the qualification that these companies provide to the bonds, the qualification affects the yield, and the yield affects the price. The higher qualifications means lower yield and higher prices. And the problems translate into how much should the price be for a particular yield. And that's the kind of problem we're going to be solving in many examples. The other problem that we might be solving is what's the yield if we know the purchase and selling price of a particular bond. So we have this image here in which we can represent the purchase price, and this purchase price could be the face value, it could be something else, and then this something else might, again, would depend on the yield that the market is accepting for this particular company, given their performance and financial conditions. The coupons are based on the actual face value and the bond rate. That is what the original contract in the paper was. And then the selling price, depending on what happens, if it's sold before the maturity of the bond, the selling price might be what the market accepts. But if it's at the end of the end of the life of the bond, typically bonds have a life of 10, maybe 10 years, maybe up to 30 years. Then the selling price in theory should be the face value, and the investor should receive back the face value. So those are the situations, and the present value, that would be the purchase price of the bond, would be the coupon, which is the face value times the bond rate times P given A. For the yield, the interest rate that we need to use here is the yield, and the number of periods left until maturity, plus the future value, the selling price that we're going to get. That could be the face value, it could be something else, times P given F. It's only one single time that we're going to receive this amount, discounted at the yield rate and the number of periods left till maturity. So with this formula we can solve a problem about bonds. Let's try it. So here we have a problem in which the face value, let's say it's $1,000, and the bond rate is 5%, and the coupon is $50, therefore, because 5% of 1,000 is $50. We have 8 years until we reach maturity of the bond, and the market is, given this corporation, is paying a yield of 4%. So we read present value equals, now we have coupons of $50, and we have P. We're going to bring back all those coupons to the present. The interest rate that we want to discount is the yield 4%. We have 8 coupons like that, plus $1,000 that we're going to receive at the end of the life, and we're going to receive it only once, so it's P given F for 4% and 8 periods later on. So the present value would be $1,067.33, and as you can see, the price is larger than the actual face value because the yield 4% is less than the bond rate, which is 5%. So we're paying a higher price and a lower yield because chances are this is a very good company, and we're pretty sure that we're going to get our money back.